Hi everyone. Wanted to work through a couple more stoichiometry problems with you. This is worksheet 2, and I've decided to start with number 5 on the worksheet. Okay, so here we are. We're looking at number 5, and there are a few things that we're going to do in this problem. We're going to um, we're going to find out how many moles of oxygen. I'm sorry, how many moles of iron can be converted into magnetite. We're going to find out how much magnetite we can actually make, and we're going to calculate the mass of the oxygen needed. Okay. Now, the reason I want to get into this is because up to this point, we've only been dealing with moles. All right. And it's really important that you understand that we can't just, you know, only work with moles. In order to count moles, we have to use mass. Um, Mass is necessary to convert to moles, and moles is necessary to convert back to mass. All right, let's take a look at this first one together. All right, so I'm just going to fill in what's given in the problem. So I'm looking at A. How many moles of iron can be converted in the presence of 8 moles of oxygen? So all I'm doing is I'm filling in how many moles of oxygen I'm given. I'm trying to solve for this value right here. Okay? Now, the ratio between the oxygen and iron is a 2 to 3 ratio. So if you think about it, for every one oxygen, for every one oxygen, I would need 1.5 iron. For every 1 mole of oxygen, I would need 1.5 moles of iron. Okay, so I could simply just take 8 moles times 1.5, and my answer would be 12 moles. Okay, now I could also, if I wanted to, I could set this up as a proportion, which I highly encourage you to do just to make more sense out of it. I'll set up my proportion here. For every 2 oxygen, I need 3 iron. Okay, but I'm given 8 oxygen. So if I cross multiply, that's going to be 24 equals 2x. And x would be 12 moles. So, like I said, I mean, if you can do this in your head, that's fantastic. If you want to set up a proportion to really be careful about it, that's also fantastic. Just to finish up this, I'm going to use up all 12 of the iron, 12 moles, to end up with 0. I'm going to use all 8 oxygen to end up with 0. How do I know that, by the way? It's because I'm given the exact ratio of elements that we need. In other words, both reactants are the limiting reactant. All right, so how much magnetite am I going to make? In the beginning, the B part, nothing, because we haven't made anything yet. And then for the amount that we're making, why don't we just look at the ratio between oxygen and magnetite? It's a 2 to 1 ratio. So if I'm going to use up 8 oxygen, then I'll make 4 magnetite. And this is what I've made, 4 moles. Okay? The last part of this is that we're going to find the mass of the oxygen needed. All right, well, we need the molar mass of oxygen, and this is a diatomic molecule. 1 mole of oxygen is 32 grams oxygen. Okay? All right, so I'm not given 1 mole, I'm given 8 moles. So really 8 times 32 is going to be 256 grams of oxygen. Okay? Again, 1 mole is 32 grams. I'm given 8 times that much stuff. So 8 times 32, 256. Okay? Okay, let's work on number 6 then. This is still worksheet 2. And I really want you to pay attention to what's happening here. We're given a mass of hydrogen peroxide. So we're given a mass of hydrogen peroxide that's going to react here to make water and oxygen gas. Now, this is very, very important that you get this. We must always convert grams to moles. BCA tables can only work with moles. Only moles, never grams, okay? You must always convert grams to moles. So our first step here is to see how many moles of hydrogen peroxide are we given. I wrote the molar mass for hydrogen peroxide here. So we know that 1 mole of hydrogen peroxide is 34 grams. That's 2 oxygens, which is 32, and plus 2 hydrogens, which is 2. 32 plus 2 is 34. All right. Now, we've got way more than 34 grams. So we need to see how many moles 680 grams of hydrogen peroxide is going to be. Again, why don't we set this up as a proportion just to sort this out. So 1 mole is 34 grams, but we're given 680 grams. All right, so we're going to solve for x. We need to know how many moles that is. If we cross multiply, that's 34x equals 680, and x equals 20 moles. All right, so we're given 20 moles of hydrogen peroxide. Let's put that into our table. We're given 20 moles. And in the before, we have not formed any water yet. We have not formed any oxygen yet. Okay, so now let's see how many moles of oxygen we can form. All right, now that all has to do with the mole ratio. For every 2 hydrogen peroxides, I can make 1 oxygen. All right, well, if I'm going to use up all 20 of the hydrogen peroxide, I'll end up with 0. Okay, and if I'm using 20 hydrogen peroxide, I can make 10 of the water. I'm sorry, of the oxygen. I can make 10 moles of oxygen. That is the answer to that question. All right, how many moles of water are formed? Okay, well, let's take another look at this. Whoops, wrong button. Let's take another look. For every 2 hydrogen peroxides, I can make 2 waters. That's a 1-to-1 ratio. If I'm using up 20 hydrogen peroxides, that means I'm making 20 moles of water. So this answer is 20 moles. All right, now the rest of it is just converting to mass, all right? We take the number of moles and convert that to mass. For oxygen gas, 1 mole of oxygen gas is 32 grams. Okay, we were given, or we made 10 moles of oxygen. So that's going to be 10 times 32. That's going to be 320 grams of oxygen. 320 grams. Okay. The mass of water that is formed. Okay, the amount of water that we've made is 20 moles. H2O. Maybe I should first say that 1 mole of water is 18 grams. Okay. All right. So 20 times 18 is going to be 360 grams of water. Okay. Now, an interesting side note I think would be worthwhile showing you. That's 320 grams of oxygen. That's 360 grams of water. If we add those together, that is 680 grams of product. 680 grams of product. Well, that makes perfect sense because we started with 680 grams of hydrogen peroxide. Remember the law of conservation of mass. We have not created or destroyed anything. We started with 680 grams of hydrogen peroxide, and we made 680 grams of product, and that was the oxygen plus the water. So I think that's worthwhile showing you. Okay, so I think that's going to do it for this worksheet. I just wanted to choose a couple to work through. The answers to all of these problems are going to be found in the student resource folder, but I'm not going to work through every single one as a video. But I chose a couple here, and I hope that was helpful. Thank you.